lab 10, experiment 1, which is the work done by a spring. Here are the tools I used, the spring scale and the ruler. And basically for the post-lab questions, they're asking the first one says create a force versus displacement stretch graph like in the pre-lab. So here is the graph I created, which I'll upload a picture later and you can see more clearly, but basically it's just kind of a consistent diagonal line. So for every time the distance increases, the force increases as well. Then it says, using the result of pre-lab question 1, calculate the work done by a spring. And so I found out in pre-lab question 1 that the equation for work is W equals K squared over 2. And I basically just used that equation to calculate the work. And then 3 says the work done by a spring can be broken down by the work done by each centimeter stretch. Fill in the rest of table 1 to calculate the average force applied by the spring over each 1 centimeter stretch. And so basically what I did is after I found out what the force and the distance were, I basically just multiplied those two numbers together, divided them by 2, and then I got the average force in newtons. Yeah, so that's basically what I did for experiment 1. And then for experiment 2, I was just filling out the table with the different balls. So I used a basketball, a softball, a ping pong ball, a tape measure, and some tape to measure the different heights that the balls bounced at. And then for the first post-lab question, it says use table 3 to calculate the potential and kinetic energy of each ball during different stages of its motion, and then it said record it in the table. So here are my tables, which again I'll upload them so that they're more clear. But basically for each the potential and the kinetic energy, I basically took the different masses that were provided, and then I multiplied them by like the average height to get the potential and kinetic energy. Or for the potential, I did that to get the potential energy, but then the kinetic energy equation is 1/2 times mass times volume squared. So I used that to get the kinetic energy. And then I wasn't quite sure what to do for the thermal energy, so I left that column blank, but everything else I tried to fill out. And yeah, that's pretty much it for those 2 labs.